Welcome to this video that discusses Analytics Solver Platform's Sensitivity Report. After Solver has found a solution to a model, the Sensitivity Report will be available under Reports, Optimization. When sensitivity is selected, Solver will produce a report that provides classical sensitivity analysis information for both linear and nonlinear programming problems, including dual values and range information. At the top of the answer report, you'll find the worksheet name, the date and time that the report was created, and the engine that was used to solve the model. In this case, we used the LP quadratic engine to solve the linear product mix model from our previous videos. First, we have the objective function with the final value. Next, we have the decision variables with their final values, reduced costs, coefficients, and allowable increase and allowable decrease. The reduced costs for a variable is non-zero only when the variable's value is equal to its upper or lower bound in the final solution. In this example, producing one speaker will decrease our total profit by $2.50. Loosening the bound will improve the objective. In this example, if I were to decrease the lower bound 1 unit from 0 to -1, the objective would improve or get larger by $2.50. Of course, it's impossible to create a negative amount of products. In the case of linear models, such as this one, the reduced cost will remain constant over the allowable increase and decrease interval. In this example, we'd still build 200 TVs even if the profitability of TVs, or the $75 coefficient value, decreased by $5 or increased by $25. Beyond these points, or if the unit profit for speakers increased by more than $2.50, we'd start building speakers. Now on to the constraints. For constraints, the sensitivity report lists the final values of the constraint left and right-hand sides, the shadow price, and the allowable increase and allowable decrease. The shadow price for a constraint is non-zero only when the constraint is equal to its bound. This is called a binding constraint. Again, loosening the bound will improve the objective function value, and tightening the bound will worsen the objective function value. In this example, increasing the number of electronic units from 600 to 601 will allow Solver to increase total profit by $25. We could use up to 50 more electronics units, which we'd use to build more TVs instead of stereos, thereby increasing our profits by $25 per unit. A value of 1e to the plus 30 in this report represents infinity. In this example, we would not build any speakers regardless of how much profit the profit per speaker decreased. Now let's go back to our original worksheet and solve the model with the GRG nonlinear engine. And let's create a second sensitivity report. The main differences between this report and the report created by the LP quadratic engine is that the reduced costs and shadow prices are referred to as reduced gradients and Lagrange multipliers, and the allowable increase and allowable decrease columns are not present. This is because Lagrange multipliers are valid only at the single point of the optimal solution. If there is any curvature involved, the Lagrange multipliers begin to change as soon as we move away from the optimal solution. If you compare the two reports, you'll notice that both the reduced gradients and the reduced costs are identical. This is also true when comparing the Lagrange multipliers against the shadow prices. This concludes this video on Solver's sensitivity report. To contact our technical support staff, please click the link that appears on the screen now.